Assalamualaikum warahmatullahi wabarakatuh. Let me introduce myself. My name is Muhammad Rafif. I'm from I'm majoring in Informatic Engineering from Trilogi University, and my name is 181070010. Okay, this is was my this is my presentation about my program of detection of four-wheel vehicles that gets Pertalite fuel subsidies using your You Only Look Once version 3 or YOLO V3. Before I explain the code that I use, I'm going to show the file that we are going to use and upload it to the Google Colab Pro for this program, which is OBG data, OBG name, object detection, YOLO, test 1, test 2, test 3, test 4 is a image that we are going to use for detecting it, and YOLO V3 custom configuration, YOLO V3 custom final weights. So I'm going to explain my code. The first I'm using OPENCV 2 version 2 or import CV2, and I'm using NumPy as I'm aliasing it as NP, and from google.colab.pages import the cv2.I'm show to show the image that I'm using. The first step is I'm going to load the YOLO algorithm, which is YOLO V3 custom final weights and YOLO V3 custom configuration, and uploading the classes, which I'm using two classes, CGC and LMPV, and will be fitting into this variable classes. And next is defining layer names. This was the function to finding the layer names and will be append in the classes. Okay. After that, we're going to load the uploading the image using this function emg equals cv2.imread, and was the test for from the file that I was upload. I'm going to detect it is layer and height with it channels in emg.shape. After uploading the image, we are going to extracting feature to detect the object using this BLOB. BLOB equals cv2.dnn.blob from image. BLOB is a function to extract heights with it channels that from this image dot shape, that the image that we are uploading, and we'll be passing in into the outsnet.forward output layers this function to see the result of the output layers, to find the output layers. Okay. For that, we have these three: class ID, confidence, and boxes. To find detecting in confidence in using the three step, which are scores, class ID, and confidence. The first step, we are going to detect the detecting confidence. The first step is finding the scores of the detection and input it into the variable scores. And the second step is finding the highest scores, and we are going to fit in into the class ID, variable class ID, and uh, took the took the confidence value from the scores on every array of this class ID. So next function is if confidence bigger than 0.5 is a condition. If means if the object is detected, it will be get the it will be took or taking the scores of the center X, center Y, width, and height from the bounding box. And this is the function for drawing the rectangle. Okay. After drawing the rectangle that we are going to use indexes CV2, we are going to remove the double boxes that will append in the detection in the process of the detection. using the non-maxima suppression. In this function, non-maxima suppression is for erasing the double boxes or the grid from the bounding box, which will make the detection is confused. So we are going to use these non-maxima suppression boxes using these indexes x, y, w, and h. Width and height is for making boxes. Label is for giving the class of the object that we are going to detect it, which are classes is LMPV and LCGC. And confidence I is for showing the confidence value. CVD dot rectangle EMG XY X plus W Y double plus H is for drawing the rectangle of the bounding box. And CV2 dot put text EMG label is for giving a text of the images of the object that we are detecting, such as LCGC, LMPV, and the scores of the accuracy or confidence. CV2 underscore I'm show EMG is for showing the result of the detection, and CV2 dot wait key is for closing the tape. So we are going to run it on test one first. Image test one, change this one as this. Let's try running it. Okay, so here it goes. Is the result. This is a Datsun Go. This this was a LCGC type of car, and which class is correctly detected, and the accuracy is 1.0 or 100%. Okay, we are trying to do the another image. We are going to detecting test two, running it again. Okay, this is the type of LMPV car which the class are shown correctly, and the accuracy was 1.0 or 100%, and the accuracy of this image that object detected is 100%. Okay, we're going to do the same thing into the test tree, running it again. Okay, this is the type of LCGC cars, which class is showing correctly, and we get a different accuracy score like the test 2 and test 1, with it is 0.199 or 99% accuracy. And the last one is test 4, do the same thing and running it again. And the last one is a LMPV type of LMPV class type of car, and the classes were showing it correctly, and the accuracy was 1.0 or 100%. So that's all about my presentation of my program from detection of of four-wheeled vehicles that get subsidies Pertalite using YOLO V3 or You Only Look Once version 3. Sincerely, I apologize. Wassalamualaikum warahmatullahi wabarakatuh.